For the next couple of days, we're going to be talking about triangle congruence postulates, and we're going to use all 6 of these postulates in proofs. So I thought it would be helpful if I gave you this foldable that's completely filled out, and it just tells you what each of these postulates are. Then we'll jump into another foldable that goes over how to use these in order to prove that triangles are congruent. So first we need to go ahead and cut this out. And then now we can fold it. So we're going to fold both sides into the center, just like so. And then we can cut each of these to make the 6 flaps. Okay, so the first postulate we have is the side, side, side postulate. And that one is if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So if we know that all 3 sides of each triangle are congruent, then we know that both of these triangles are congruent. So that's side, side, side. Then we have side, angle, side. It's just like it sounds. We're going to have a side, angle, and side that are congruent. So if 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. So that means it has to go in the order of side, angle, side. These all have to be touching. That angle has to be in between the 2 congruent sides. So side, angle, side, side, angle, side. Therefore, these 2 triangles are congruent. Then we have angle, side, angle. If 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. So again, this means that it has to go in the order angle, side, angle. So the 2 angles need to be on each side of the congruent side. So angle, side, angle, angle, side, angle. Therefore, these 2 triangles are congruent. Then we have angle, angle, side. So if 2 angles in the non-included side of one triangle are congruent to 2 angles in the corresponding non-included side of another triangle, then the triangles are congruent. So this means it's got to be angle, angle, side, angle, angle, side. So it's not going to be the side in between the 2 angles. That would be angle, side, angle. But it's going to go in the order angle, angle, and then that very next side, angle, angle, very next side. Those 2 triangles will be congruent. Then we have the hypotenuse leg. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the 2 triangles are congruent. So the important thing here is it has to be a right triangle. The hypotenuse leg postulate only works for a right triangle. And then it says that if the hypotenuses are equal in one of the legs, it doesn't matter which one, then the 2 triangles are congruent. Again, only works for right triangles. Then we have false shortcuts. So it's things we think may be postulates that don't actually work. So angle, 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 and side, side, angle. Neither of these work to prove that triangles are congruent. Angle, angle, angle. Well, all the angles can be congruent, but that doesn't mean all the sides are, because we can have 2 triangles with the same angle measures, but totally different side lengths. Side, side, angle. If we have 2 sides that are equal and one angle that's equal in that order, it doesn't necessarily prove that everything else is equal too. So we can't say triangles are congruent by these 2 things. You can go ahead and glue this in your composition notebook and title the page Triangle Congruence Postulates. And we can move on to the flip book now.